Good day, students. So this is our first lesson in Information System Analysis and Design. Okay, so the first chapter talks about the development or the system development environment. Okay, so after studying this chapter, you should be able to first define what is information system analysis and design. Next is to describe the information systems development life cycles or the SDLC. Next, the third one is to explain computer-aided software engineering tools or yung tinatawag na CASE tool. Okay, so computer-aided software engineering tools or case. Next, the fourth one is to describe the agile methodologies and extreme programming. And then the last one is to explain the object-oriented analysis and design the rational unified process RPU. Okay, so to continue, let us first define what is the information systems analysis and design. So information system analysis and design is a complex, challenging, and stimulating organizational process that a team of business and systems professionals users to develop and maintain computer-based information. So, although advances in information technology continually give us new capabilities, the analysis and design of information system is driven from organizational perspective. An organization might consist of the whole enterprise, specific departments, or individual working group. Okay, organizations can respond to the to and anticipate problems and opportunities through innovative use of information technology. Information system analysis and design is therefore an organizational improvement process. Okay, so information system analysis and design help the organization to improve. Okay, so systems are built and rebuilt for organizational benefits. Benefits result from adding value during the process of creating, producing, and supporting the organization's products and services. Thus, a system analysis and design of information system is based on your understanding of the organization's objective, structure, and processes, as well as your knowledge of how you exploit or how to exploit information technology uh, for advances. Okay, so an important result of system analysis and design is application software. So software designed to support specific organizational functions or process, okay, such as inventory management, payroll, and or market analysis. So in addition to application software, the total information systems include the hardware and software systems, okay, on which the application software runs, documentation and training materials, and the specific job roles associated with the overall system controls and the people who are about to use the software along with their works and methods. So although we will address all these various dimensions of an overall system, okay, we will emphasize the application software development and as your role, okay, your primary responsibility as an system analyst. So system analyst is an organizational role most responsible for the analysis and design of the information system. Okay, so on your screen is the figure of an organizational approach to system analysis and design, and which is driven by three elements. So the methodologies, the techniques, and then the tools. For methodologies, so that is methodologies are comprehensive, okay, multiple step approach to system development that will guide your work and influence the quality of your final project, which is the information system. A methodology adopted by an organization will be consistent with its general management style. Okay, so most methodologies incorporated several development techniques. Okay, the second one is the techniques. Techniques are particular process that you as an analyst will follow to help ensure that your work is well throughout, complete, and comprehensible to other on your project team. Techniques provide support for a wide range of tasks, including conducting thorough interviews to determine what your system should do. Okay, planning and managing the activities in the system development project, diagramming the system logic, and designing the reports of your system will generate. Okay, and then the last one is the tools. So tools are typically computer programs that make it easy to use and benefits from techniques and to faithfully follow the guidelines of the overall development methodologies. To be effective, techniques and tools must be both consistent with an organizational system development methodology. So technique and tools must make it easy for the system developer to conduct the steps called for the methodology. Okay, so that is the three elements of methodology. Okay, so now let's go to a modern approach to system analysis and design. Okay, so the analysis and design of computer-based information systems began in 1950s. Since then, the development environment has changed dramatically, driven by organizational needs as well as by rapid changes in the technological capabilities of computers. So in 1950s, uh, development focused on the process of software perform because computer power was a critical resource. Okay, efficient uh, processing became the main goal. Computers were large, expensive, and not very reliable. So during that time, computers are somewhat like same yung size ng isang room. So doon mo makikita nyo parang yung isang kwarto ay isang computer. Okay. So emphasis was placed on automating existing process such as purchasing or paying often within a single department. Okay, so all application had to be developed in the machine language or assembly language, and they had to be developed from scratch because there was no software industry. Okay, when we talk about the machine language or assembly language, okay, ang machine language kasi ito yung 01. Okay, kung natatandaan nyo siya sa computer programming nyo, yung tinatawag na binary language, yung 0101, 0001. So each letter of the computer corresponds to binary or machine language na binary language. Okay, so because computers were so expensive, computer memory was also at a premium. So system developers conserve as much memory as possible for data storage. Okay. First, procedural and the or third generation computer programming language did not become available until the beginning of 1960s. Okay, so that is the advent of procedural third generation language or 3GL. So that is faster and more reliable computers. Okay, so during the time computers were still large and expensive, but in 1960s, shows important breakthrough in technology that enables the development of smaller, faster, less expensive computers. So, nandiyan na yung birth of microcomputers. Okay, and from the scratch using their in-house development staff. Okay, system development was more an art than science. Okay, so during that time system development, sabi nga dyan, was more on art than science. So ngayon kasi parang science ang system development is more on science na. Okay, so this view system development began to change in 1970s. Okay, however, an organization started to realize how expensive it was to develop customized information system for every application. System development came to be more disciplined as many people work to make it more likely engineering. Okay, so early database management system during hierarchical network models help bring discipline, okay, to the storage of and retrieval of data. So the development of database management system helps shifts the focus of system development from the process first to data first. The 1980s were marked by major breakthroughs in computing organizations, so as microcomputers became key organizational tools. The software industry expanded greatly as more as people began to write off-the-shelf software from microcomputers. Developers began to write more and more application in fourth-generation language, which, unlike procedural language, instructed the computer or a computer on what to do instead of how to do it. Computer-aided software engineering or CASE tools were developed to make system developers work easier and more consistent. As computers continue to get smaller, faster, and cheaper, and as operating system for computers move away from line prompt interface to Windows and icon-based interfaces. Okay, so organization move to application with more graphics. So organizations develop less software in-house and bought relative more from software vendors. The system developer's job went through a transition from builder to integrator. The system developer environment in late 1990s focused the system integration. Developers use visual programming environments such as Power Builder or the Visual Basic to design the user interface for system that runs on client server or platform. Okay, so the database, which may be relational or object-oriented, and which may have been developed using software from firms such as Oracle, Microsoft, Ingress reside on the server. In many cases, the application logic reside on the same server. Alternatively, an organization may have decided to purchase its enterprise-wide system from companies such as SAP, AG, or Oracle. So those are the big software companies. Okay, so enterprise-wide system are large complex system that consists a series of independent system modules. So the developer assemble system by choosing and implementing specific modules. So starting in the middle years of 1990s. More and more system development efforts focus on the internet, especially the web. Okay, so today, the new century, there is continued focus on developing system for internet and for firms intranets and extranets. Okay, so as happened with traditional system, internet developer now rely on computer-based tools to speed and simplify the development of web-based system. Many case tool, okay, directly support web application development. More and more system implementation involves the three-year design with the database on one server, the application the second server, and the client logic located on user machine. Another important development is the move to wireless system component. Okay, wireless device can access web-based application from almost anywhere. And finally, the trend continues toward assembling systems from programs and component purchase off the shelf. So in many cases, organizations do not develop the application in-house. So they don't even run application in-house. So choosing instead to use the application on the per use basis by assessing it through the crowd. Now let's talk about the developing information systems. Okay, so most of organizations find it beneficial to use a standard set of steps called a system development methodology. So it is a standard process followed in an organization to conduct all the steps necessary to analyze, design, implement, and maintain the information system. Okay, so like many other process, okay, the development of information system often follows the life cycle. So for example, a commercial product follows a life cycle in that it is created, tested, and produced to the market. Its sales increase, peak, and decline. So finally, the product is removed from the market and replaced by another something else. The System Development Lifecycle, or SDLC, is a common methodology for the system development in many organizations. It features several phases that mark the progress of the system analysis and design effort. Every textbook author and information system developed organization uses slightly different life cycle model, with anywhere from 3 to almost 20 identifiable phases. So the phases in SDLC, or System Development Lifecycle, are the planning, analysis, design, implementation, and maintenance. Okay, so the life cycle can be thought of as a circular process in which at the end of the useful life of one system leads to the bringing or beginning of another project that will develop a new version or replace an existing system altogether. So just like in figure 1-2. So that is the system development life cycle. So starting from planning, next is analysis, design, implementation, then maintenance. So after maintenance, if there is a need to revise the system, okay, so it will start all over again from planning, the revision, analysis of the revision, designing the revision, implementation of revision, and then the maintenance of revision. So that's why some application or system has a version. So from version 0, version 1, version 2, version 3. So that is the result of uh, SDLC, or System Development Life Cycles. So some other developers uses evolutionary model. So it start from planning. So it is just a spiral model. Okay, so planning, analysis, design, implementation. Okay, and then maintenance. So it is same thing, same. It is just like SDLC, pero sa SDLC, circular siya. So unlike sa evolutionary, okay, so spiral siya. Okay, so next is, okay, so now let's talk about the system development life cycle. So each phases. So let's start with planning. So according to the slide, an organization's total information system needs to be identified, analyzed, prioritized, and arranged. So planning is one of the most difficult part of or phase of system development lifecycle, because here we're going to identify the problem, okay, prioritize the problem, arrange solution, and everything. Next is for the analysis. So analysis system requires are studied and structured. So after identifying, okay, the requirements of the system, okay, so analysis phase are focused in studying and structuring the plan. Okay, next is or structuring the system. Next is the third one, the design as description of the recommended solution is converted into logical and then physical system specifications. So after studying or after analyzing, you're going to have a design or of the physical system. Okay, here you're going to identify the specification of the system. Okay, so in design phase, so it is divided into two groups or two parts, which is the logical design and then the physical design. So in logical design, all functional features of the system chosen from development in analysis are described independently of any computer platform. So here we're going to talk about the specification of the design of your system in terms of platform. Okay, now for physical design, the logical specification of the system from logical design are transformed into technology specific. Okay, so details from which all programming and system construction can be accomplished. So physical design, kung sa logical design, ito yung pinakalaman, okay, ng system, the code, okay. Sa physical design naman, ito naman yung mga nakikita, physical, something tangible. Ano ba yung design ng, ng system mo? Ano ba yung itsura niyan? Okay, so then the next space is the implementation. The information system is coded, tested, installed, and supported in the organization. So after designing, so na-code na yung yung system, so ite-test na siya, i-installed, and then susupport na siya. So that is for the implementation. And then the last phase is the maintenance. An information system is systematically repaired and improved. So, kapag nakagawa na ng system, hindi din siya natatapos ng ganun lang. So, may maintenance yan. So, still, meron pa rin yan, repair pa rin yan. May kailangan pa rin i-repair or kailangan pa rin i-improve. So, here are the products of SDLC paces. Okay, so let's start for paces, and then on the table you can see the product outputs and deliverables. So let's start with planning. Okay, so planning, ang products and outputs niya or deliverables are prioritized for system and project, and architecture for data networks and selection hardware, and information system management are the result of associated system. Okay, so dyan selection siya ng hardware na gagamitin. Next, detailed step or work plan for the project. Okay. Next is specification of system scope and planning and high-level system requirements or features. Next is assignment of team members and other resources. And then the last one is system justification or business case. For analysis phase, each product output and deliverables is description of current system and where problems or opportunities exist. Okay, so with a general recommendation on how to fix, enhance, and or repair current system. Okay, so next one is explanation of alternative system and justification for chosen alternative. So as far as I recall, analysis based na dyan si SWOT analysis. Alam nyo yun, yung SWOT analysis. Okay, yung strength, weakness, opportunities, and threat. Okay, yung SWOT analysis. So, under siya sa analysis phase of SDLC. The third one is design. Its products, outputs, and deliverables are functional, detailed specification of all system elements such as data, process, input, and outputs. The next one is technical. Okay, detailed specification of all system elements such as program, files, networks, system software, etc. And then the last one, acquisition, plan for new technology. Okay, and then the fourth one is implementation maintenance. So here the product is code, documentation, training procedure, and support capabilities. Okay, so the new versions of release or release of software with associated updates to documentation, training, and support. Okay, so on your screen is the specialized system development life cycles. So this is used by Microsoft and they called it as Microsoft Security Development Life Cycles. So it starts with training, requirements, design, implementation, verification, release, and response. In training, okay, so training focuses on security. Okay, so they used to train for the security of the system. Next is requirements. Okay, so design implementation. So these are like traditional analysis, design, and implementation. Okay, so the fifth one is verification. Okay, so focuses on the product quality and assurance. And then release. Okay, make product available for general use. And then the last time is response, where it deals with security problems that come up after release. Okay, so this is the heart of the system development. Okay, in coding, okay, the current practice combine analysis, design, okay, and implementation into single, iterative, and parallel process of activities. Okay, so in figure 1, you can see the cycle. So from analysis, design, code, and then test. Analysis, design, code, test. So that is what we call the analysis, design, code, test loop. Okay. Next in figure 1 point or 1-9, so you can see the heart of the system development. Okay, so nag-start siya sa analysis, design. Okay, in SDLC, yung part na analysis, design, loop, test, ulit. System design, code, test loop. Okay, nandoon siya sa part ng analysis and design. Kasi, okay, after analyzing, magde-design ka and then you're going to analyze if your design is good or will fit as required ng organization. So, nandiyan dyan talaga. Kumbaga, pag sa system, dyan tumitibok. Yan yung tibok ng puso ng ng system. So, sana all tumitibok yung puso. Okay, so this is the another type of SDLC. Okay, so that is what we call the waterfall. Okay, so one phase begin when another phase complete with little backtracking and looping. Okay, so planning, after planning, it jumps to analysis. Let's jump to logical design, physical design, implementation, and maintenance. So, parang ang style dito, after maintenance, wala na ulit another planning. Siguro ito yung mga one-time, mga one-time system. Okay, na hindi kailangan ng revision or version. Okay, so problem with waterfall approach, feedback ignored. Okay, milestone lock in design phase when condition change. So, kapag natapos yung system, so ano man feedback ang marinig nila, hindi nila basta ang system tapos. Okay, so limited user involved only in requirement phase. Okay, so kung ano lang yung hiningi ng requirements, wala nang improvement. Okay. Next is too much focus on milestone deadlines of SDLC phase to the treatment of sound development practice. So since dito parang hindi open yung time dito for revision or for improvement kasi nga nakafocus sa deadline na kailangan pag natapos yung SDLC tapos agad yon. Okay, so hindi na nagkakaroon ng in-depth analysis and then after maintenance or implementation where they're going back to another version to have another plan. Okay, so yun. Okay, different approach to improving developments. So those are the case tool or aided software engineering tools, the agile methodologies, and extreme programming. Okay, So let's start with CASE, or Computer Aided Software Engineering Tools. So diagramming tools enable graphical presentation. So dito, may graphical presentation na. And then makikita mo na yung mga icons sa Computer Aided Software Engineering. Next is Computer Display and Report Generators help prototype how the system look at and feel. Okay, so may mga reports generator na dito, yung tinatawag na crystal reports, so something like that. Then building reports or report builder. Okay, so another thing, analysis tools automatically check for consistency in diagram, forms, and report. Okay, so kapag gumagawa ka ng sa computer aided engineering, kapag ginagawa mo yung system, chine-check mo na dito yung consistency ng diagrams, ng forms, and then reports. So, ayos ba yung location ng mga icons? Okay, kapag gumawa ka ng form. Okay, kapag nag-generate ba ng report, tama ba yung i-release ng reports, especially when sa accounting. Okay, so dapat kapag gumawa kayo ng system about accounting, okay, so make sure na tama iyon kapag manual check natin. Okay, yun, halimbawa kayo gagawa, so bago nyo siya ipasa, kapag nag-generate yung report nun, kina-counter check nyo yan manual, na dapat ganito yung sagot nyan. Halimbawa sa balance sheet, okay, sa ledger, dapat ano yun. Okay, next is central reposition provides integrate storage of diagrams, reports, and project management specification. So, dapat ang database mo dito is maayos na i-store yung mga diagrams, yung report, and even your project management. Okay, so that is for your future use. Okay, documentation generator, standardized technical and users documentation. Okay, so yung sa documentation generators, standardized technical, ito yung documentation mo ng code mo, yung tinatawag na source code. Okay, so kailangan well documented yun. So from yung code on how you will going to do the form, okay, yung each button doon, dapat may mga code yun. Okay, so dapat well documented yon, and even your user documentation, ito yung user manual, so paano ba gamitin ng system mo, so kailangan meron yon. Okay, next is the code generator, enable automatic generation of programs and database code directly from design documents, diagrams, forms, and reports. So connected ang code generator, okay, ng program at ang database sa design ng documents, sa diagrams, and then forms, and then reports. So, kailangan kapag yung sa documents, kumbaga, naka-database yun, connected sa database. Okay, so here's the examples of case usage in or within the SDLC. Okay, on the table, yung first column, nandiyan dyan si SDLC phase. Next is key activities, and then the last column, case tool usage. So, yung gamit ng case, okay, sa SDLC. Okay, so the first one is project identification and selection. Okay, the key activities for that is display and structure high-level organizational information. And then for the case tool, diagramming and matrix tool, to create and structure information. Okay. Next is project initiation and planning. So, develop project scope and feasibilities. Okay. So, in case tool usage, repository and documentation generators to develop project plans. Okay. The third one is analysis. Determine and structure system requirements. And then for the case tool, diagramming and create process logic and data models. Okay, so logical and physical design, key activities, create new system designs. Okay, for case tool usage, forms, and report generators to prototype design, analysis and documentation generators to define specifications. Okay, the next one is implementation. Key activities is to translate design into information system. And then for the case tool usage, code generator and analysis uh, from form and report generators to develop system. Documentation and generators to develop system and user documentation. And then for the last one, which is the maintenance, so evolved information system. And then for the case tools, so all tools are used, repeated or repeat life cycles. So that is the usage of case tool within the SDLC. Okay, so next is the agile methodologies. So it is motivated by recognition of software development as fluid, unpredictable, and dynamic. So ano ba yung characteristic ng fluid? 'Di ba, sumusunod sa molde 'yon. And then unpredictable, so no specific parang there is something new, parang gano'n. Hindi siya talaga nagka-come up sa isa kasi nga fluid siya kung ano yung sunod sa agos. And then next one is dynamic. So may changes. Okay, so according to Fowler, so there are three principles that agile methodologies follows. Okay, so number one is the adaptive rather than predictive. Okay, so next one, kasi nga 'di ba nga unpredictable siya. Okay, mas kumbaga ina-adapt niya yung current situation o yung kailangan ng system kaysa pinipredict mo kung ano yung kailangan niyang gawin. Okay, next is emphasize people rather than roles. And then the third one is self-adaptive process. Okay. So, Agile methodologies group argues that software development methodologies adapted from engineering generally do not fit with real-world software development. So, yung daw engineering ng software development or like computer engineering niya, hindi nagpi-fit daw sa real-world software development. Kasi nga, hindi siya dynamic at hindi siya fluid type. Okay, so table 1-3 is the Agile Manifesto for software development. Okay, so 17 anarchists agrees that we are uncovering better ways of developing software by doing it and helping others to do it. So, okay, through this work we have come to value. Okay, number one, individuals and interaction over process and tools. Okay, working software over comprehensive documentation, customer collaboration over contacts negotiation, responding to change over following the plan. Okay, so that is while we value the items on the right, we have valued the items on the left more. We follow the following principle. Our highest priority is to satisfy the customer through early and continuous delivering of the valuable software. Okay, next is welcome changing requirements. Okay, so yun yung sinasabing dynamic. Okay, even late in development, so agile process harness change for the customer's competitive advancement. Okay, so deliver working software frequently from a couple of weeks to a couple of months with a preference to be shorter time scale. Next is business people and developers work together daily throughout the project. Okay, the next one is build project around motivated individuals, so give them environment and support they needs and trust them to get the job done. Okay, the most efficient and effective method of conveying information to and within the development team is face-to-face conversations. Okay, next is working software is the primary measure to progress. Continuous attention to technical excellence and good design enhances agility. Okay, agile process promotes sustainable development. So the sponsors, developers, and users should be able to maintain a constant pace indefinitely rather. Okay, simplicity, the art of maximizing the amount of work done is essential. Not done is essential. The best architectures, requirements, and design emerge from self-organizing team. At regular intervals, the team reflects on how to become more effective then tunes and adjust the behavior accordingly. Okay, so those are the principles made by the 17 anarchies of the Agile Manifesto. Okay, so when to use Agile methodologies? So if your project involves, number one, unpredictable and dynamic requirements. Okay, so responsible to motivate developers and customer who understand the process and will get involved. Okay, si customer, so may alam sa programming. So, yun yung ano nun. Yun yung ibig niya din sabihin dun. When he talk about that, customer get involved with the process. Okay, so 5 critical factors that distinguish agile and traditional approach of the system development. Okay, so first column is the factor, second column is agile method, and then the third column is the traditional methods. Okay, so in terms of size, for agile will match to small products and teams. Okay, reliance on tactic knowledge limits scalability rather. Okay, next is for the traditional method evolves to handle large product and terms. Okay, hard to tailor down to small project. Okay, so for critical aspect or criticality, okay, so sa agile method, untested on safety, critical products, potential difficulty with simple design, and lack of documentation. While for the traditional methods, okay, methods evolved to handle highly critical products, so hard to tailor down the products that are not critical. Okay, dynamism, okay, simple design and continuous refactoring are excellent and highly dynamic environments, but a source of potential expensive rework for highly stable environments. So that is for the agile method. And then for the traditional method, detailed plans and big design upfront, excellent for highly stable environment, but a source expensive rework for highly dynamic environments. Okay, in terms of personnel, for the agile method required continuous presence of the critical mass of uh, scared expert. Okay, risky to use non-agile people. Okay, so for traditional, needs a critical mass of scarce expert during project definition, but can work with fewer later in the project unless environment is highly dynamic. And last one for culture, strive in a culture where people feel comfortable and empowered by having many degrees of freedom, striving on chaos. And then for the traditional, strive in the culture where people feel comfortable and powered by having their roles defined by clear practice and procedure, so striving on order. Okay, so the last one is extreme programming. So this is short incremental development cycle. So this is short, ibig sabihin, konti lang, maikli lang. Automated tests, automatic testing, Okay, two-person programming teams and coding, testing, listening, designing. So, yun sa extreme programming. Okay, so coding and testing operates together. So, while you code, you test. Okay, so yun yung sa extreme programming. Advantages nito is communication between developer. Okay, so you have direct communication between the developer. Okay, so this is what you want to do. Yung parang ganon. High level of productivity. Kasi nga, since coding and testing operate together, yung product mo, pag natapos siya, yun talaga high level yung quality niya. Okay. Next is high quality code. Ayan, so nabanggit ko na high quality code. Kasi nga, may coding and testing ka na together na ino-operate mo yun. Okay. Okay, so now let's talk about the Object-Oriented Analysis and Design or OOAD. Okay, so this is based on object rather than data or process. Okay, sa object-oriented, gumagamit ka ng object kesa data kasi sometimes data yung sa command prompt. Okay, so yun yung kinatawag na line coding. Diba? May code tayo na halimbawa, yung configuring, diba? ipconfig, so something like that. Okay, pero dito sa object-oriented design, okay, so for example, yung save, yung object na save, so kumbaga, ito yung mga object na yun is structured encapsulating attributes and behavior of real-world entity. Kapag pinindot mo yung save, nagsisave talaga siya. So, encapsulated na yung attributes niya. Okay, next is the object class, a logical grouping of objects sharing the same attributes and behavior. So, through that object, so pag sinasama-sama mo siya, so ang tawag na doon ay object class, pero kailangan they have the same attributes and behavior. So next one is inheritance. So hierarchical arrangement of classes. Okay, enable subclasses to inherit properties of superclasses. Okay, once ang classes ay na-arrange into nagiging subclasses siya, so pwede siyang i-inherit as property of superclasses. Okay, so that's all for chapter 1 of ISAD or Information System Analysis and Design. Thank you for listening and God bless.